Hello. If you remember yesterday we stopped with this saying I have a small circuit here. Can you zoom it in, sir? I'd like our students to see this. Yeah, as much as you can. Yeah, that's I think that's probably the maximum. It is fine. If you remember, we started here, then I also tried to show you a small enclosure which I can build with it. I was feeling very thrilled about it. Now finally that job has been fired. I have the video there which I will show you in due course, and then this is not a symmetrical object. So lot of care has been taken, and once I put it just directly, it comes out of the machine, sits flush. See how nicely it sits. I am thrilled at it. Okay, I will put it this side, maybe it is convenient for me. Can you see here? It is absolutely flush, and more than anything else, I have a provision for a heat sink there. So this aluminum what I call part, right now no, I have not yet finished it. I have got something which fits perfectly all right. All I need to do is attach 2 more screws here, and for which also I am trying to make some arrangement and make sure that there is no short circuiting here. Compare this to what we did some years back. This was done 6 years back in a little older machine. You see this here. But of course, this is the whole thing is that we are not very sure, and then this whole thing is a chance for it to buckle. So we had to strengthen it using extra sheets on all the sides, because the building and the build up and all and the size was a problem. Right now making things like this is easy, extremely easy. There is no issue about it at all. And if you make a proper drawing with all the trouble we have taken, and then the first job, the first firing of the job, everything sits neatly inside. This is the advantage of so called 3D printing. Now one of my friends have asked me a question, sir, what next? This is as an experimental thing I wanted to show you. One more time let me tell you, this is a very miniature thing, and it is going to use 2.3 mm self tapping screws. It is a little smaller than the standard ISO. We have 2.6, 2.5, then we have 1.6 and 1.5. Compared to that, eventually this is going to sit here. This is a very far fetched idea from where we have started. See here, we did not know all that story I was telling you how to make it and all that, has all been taken care of now. The technology has also improved, and we do not even need this hard what you call metal inserts unless we want it. In fact, if you see this, next model is probably going to have a small projection here. If I have the projection, I just have to push it inside and it just stays there without anything, and I do the same projection can come out, and then I can even assemble the heat sink, and where it comes out I make some arrangement, I will have a beautiful model which works. And more than anything else, I do not know if I have shown you or anything, there are small grooves here which will make sure that a wire can sit through it. So I will have a beautifully made module from off the shelf electronics. Every time you need not invent the electronics, but you need to invent products. So I will see how it was yesterday. This is what I had shown you, then this is the detailing which I had shown you, this is the box, and this is how the whole thing was built up. Now I will see if video which I took will actually show up. Yeah, a bigger video has been taken with a big camera, but right now this is a small what do you call, I will call it a trial video to show how the parts are being built up. So just wait, I hope it loads. Yeah, it is coming there. That is Mr. Singh, my colleague, who does actually all the printing and all that. I do the talking and he does the working. Let me stop it here, rather pause it here and try to explain a few things here. First of all, this device has several stepper motors. The 4 visible ones on the top is, we have stepper motor here with a belt and which has a drive which moves it in the x direction. If I take it left to right as an x direction, and then I have one more stepper motor here which by a very clever arrangement of a belt which moves here will move this from the left and right. Advantage being we have avoided loading this high speed moving device. The minimum weight is there, and then let me play it. So, you can just, because the amount of what you call the gap which is given there is very, very small, we can't see things that easily. The video we have from this camera and one more camera, you can see it subsequently when we upload it. Can you see here, this is a spool which will feed one of the materials. In this particular machine, we can have a material which can have 2 types, meaning outside can be the basic material and inside we can have a core of any this thing, including Kevlar, including carbon fiber, and so many of those things will sit inside. We are almost coming to the end, sorry. Can you see at this point? No, let me pause it again. There is a what you call a basic chassis is there, and this is that vertical table which I showed you in the other what you call in the drawing with a peculiar what you call gamma shape. So, you have a feed screw here underneath, next set of step motors and controllers and all are there. So, this moves up and down. This will give you the z axis, the other two will give you the other axis, and in this machine they have made it a little simple by making a display directly here. So, it is easy for us, probably after we have almost come to the end of it, there is not much more to go. Okay, let us just repeat, I will leave it here. Now, here is where we come into the other what you call interesting things. Now, if you can kindly look at my monitor here. So, you see here over the years my graduate students have been working on such projects, and I will repeat it later. So, do not be what you call, did not worry too much about how you would like to see it or anything. See here. So, there is something about some lamp, and that lamp does all these functions and all. If you remember, similar lamp I had showed you here. This is a very, very interesting thing. This is the CAD model on the left side, this is the typically the rapid prototyping what we have achieved. This is what I keep telling you there. The beautiful surfaces you see here do not automatically come there, in contrast to what I have shown you already. I am going to talk a little more about it, because I am one of those, I will say, coffee addicts. Okay. Off and on, show me this, sir. Can you please show me this teacup? I would like to have warm tea. So, one student worked on it and find out whether how to satisfy my craving for caffeine. We have something and we have this. I am sure a lot of you have seen this. Now, next part of the lecture is going to be this, that somewhat related to the product that you see here at the bottom. So, kindly show me this, sir. You have seen this. Now if you see carefully in this, several things have gone into until it came here. Something else, we have a gas thing, and we have something else again here. You see this, all the beautiful stuff here and so on, and this is sort of what do you say, I will call it the ultimate thing for what the students could manage. So, I will stop here, I will get back to one sample on how to make things. So, please keep looking at it. See, if you were to go to the internet and check, if you go to the internet and check what are all the guidelines for 3D printing, I will see if this thing opens. Surprise, we do have the access, external access is there. I will just type in and see how good we are. So, if you just go and say guidelines for 3D printing, we have various things here saying guidelines for 3D printing and type of materials and so on and so on. I would like to come to one of these things which we have tried to use earlier. This is made by the manufacturer of the first Stratasys machine we have had. You will notice that this is very authentic, and even today they are one of the leaders in costly things. So, if you go down, there is a downloadable design guideline is there. Okay. Yeah, it is almost there. See this is what we have been using all along. Stratasys have been one of the people which we are familiar to work with. So, I am not very sure whether it is a heater assembly or anything. Then we have this stuff about part design considerations. Fused deposition modeling design guidelines, part design. The issue being here is to be used as a starting point in understanding the aspects of part design and preparation for components. When designing a part to be built using, build process must be considered. FDM is accomplished by extruding thin layers of molten thermoplastic layer by layer until a part is produced, because FDM produces parts with specific characteristics and so on. No? So, we have blah blah and all that, and then one of the blah blahs finally we have here saying FDM systems add small amounts of molten material in a heated environment. Warp is not a common problem. However, to avoid potential warping of a vertical walls when building thin wall sections, designers must select to add ribs and so on. So, next page gives you a lot of stuff about holes, and an FDM part are generally fractionally undersized, but tight tolerance are required. Holes will be drilled or reamed to ensure the diameter is accurate. You have seen this here now. Most important thing is here is up to a point you get accurate features. Beyond that, we need to make things by finishing them. A second operation is a must, or in case any other way is over, then we have this stuff about slice thickness and wall thickness, and you have seen this about threads. And you see the last thing here. An easier alternative is to use a tap or die to thread holes or pores. So, in case you have a thread thing, carefully if you can match the the root diameter, the manufacturer himself says kindly tap the holes. You understand? No, that is a must for it. Further, if you go down, FDM is an additive process. Undercuts or design features or O-ring grooves are easily handled without causing manufacturing issues. I agree and I do not agree also. So, in this part he has given stuff about how to reduce stress concentration, how to make it and all that, and I kept on telling you about it, saying draft is unnecessary in FDM parts, and single FDM parts as large as, I mean you can leave all that. Overhanging and non-supported features such as the top of a closed walk require foundation of support material to be built, which includes build time and material usage. So, how you orient the product on the table is very, very critical. You have seen that, no? So, a little bit of data, I mean what do you call thing is they are saying parts may be sectioned prior to manufacturing in CAD, commercial rapid prototyping software, or by this direct manufacturing. So, parts that are too big for the build chamber into smaller parts, eliminate excessive amount of support structures, cut overhanging features from the top of the part, preserve fragile features that may be damaged in processing, section fragile features from the part and build them separately. Then we have living hinge for a critical thing is I have explained to you there for a prototype purposes. For a small number of cycles you can bend the material. In addition, cycles are required, consider using a different hinge design. So, we have here a nice what do you call, you have seen this, no? I do not know what it is, but you see here something very, very interesting to do is you see these mounting holes, and also you see something here on top, probably that takes a strap. I do not know if it is a connector or whether a wire is coming here or what it is. You see that lot of detailing is slightly different from equivalent injection molded part. And when using fastening hardware, use a cap screw or a flanged cap screw. The flat surface eliminates multi-directional stresses from cracking the part. Washers can also be used to spread the load. So, this is a must. So, you make your thing as best you can do, and they have given here saying in the final job around 16 point is something which you can build. So, then many times the design of an FDM part can be solid rather than using a hollowed out design supported by bosses and ribs. This can reduce build time and use less support material. It is not necessary to reduce wall thickness of a boss, rib or a gusset in FDM parts. Why they have done it? No? Because unlike in the injection molded process, here there is no, I mean there is nothing wrong in having varying cross sections. And you see here the second point, FDM process uses engineering grade thermoplastic. The parts produced are capable of withstanding a number of post manufacturing processes including machining, drilling and tapping, sawing, turning and milling. Heat is easily built up in plastic, so remove the material slowly and use usual stuff, how to do it. Now, I will quit this particular thing and go back to other considerations. I will say, yeah. This is what I have shown you. Now, other people also know, for example, design considerations, stuff, they are equally valid. Why I am showing you this is, I have experienced only one machine, one type of jobs, but here obviously there are people who have been working on it, and this is probably a book like thing is available. This is the picture I showed you earlier. See, we have a lot of guidelines given here saying what to do with supported walls. So, we have stereolithography, selective layer sintering, okay, and fused deposition, and fused modeling and all that. No, lot of stuff about what is the minimum thickness that you can have has been given here. Support and overhang. Can you see here? I will try to enlarge it as much as I can. See here the movement. There is an angled wall, it ends up with this red colored thing, is the support which is built automatically into the machine. This machine will give you this building things about it. Then you have embossed and engraving detail, that is how deep something can be or how it is there. So, they have given here 0.5 mm. Then there are bridges saying if you have a hollow span, a technology can print without the need for support. How much of? As you keep building, you can build something across, and you see here, if you see these things here, you see this hole in between, there is no support. Similarly here, no support here, no support here. Happily it is able to build. Then diameter, minimum diameter can successfully print a hole. Most of the time it is about this much, around 2 mm. Secondly, recommended clearance between two moving or connecting parts, saying if you give around 0.5 mm, it will be able to build this thing. Escape. Escape holes to allow for the removal of build material. So, they have given stuff, the size of the features, then the pin diameter features. How well? Typically around 3 millimeters is the pin which can stand by itself. There is also related to the height also about it. So, it is not correct for us to make thin tall pins here. Next we have the dimensional accuracy or tolerance. A given feature can increase by around 0.5 millimeters. So, you need to compensate for this and make sure eventually these are the design rules which we require to follow. So, in case you have any doubt so you just need to look up on the net, and I am sure you will be able to A. Invariably, we need to generate what is called a STL file. This stereolithography file is the one that learn how to avoid low quality prints or unnecessary large files by exporting in the correct resolution. Most important seems to be that saying. First of all, standard triangle language is a standard for type of 3D printing. It uses a series of triangles to represent all modern CAD software allow you to export that native thing to these triangles which I have shown you yesterday. If you make a square hole, the file is likely to be smaller. 3D model is then converted into machine language through a process called slicing. The article will teach you and so on. So, I suggest you go to this saying 3D Hub's knowledge base and finding out how these things work. I think you should read it yourself. My reading it on the screen will not help. Spend more time and you can check and choose the exporting parameters. So, usually the stuff about the recommended value for the thing is 1/20th of the layer. So, it should be actually here is given 1 micron. I will say even it should not be less than 10 microns. This will result in file which will deal accuracy for most 3D printing. Exporting in a smaller tolerance will not have any effect on the quality. So, there is no problem. Then it comes to angular tolerance between the normals. So, exporting STL file from your this thing, no, often. So, he has given several of them including SolidWorks, Save As, then 3ds Max, then he has given Autodesk, then so many other things, no, including the Inventor, then Onshape, then PTC, then Rhino. What I have been using is a what you call license for lecturers. Select stereo lithography, no, that is word I keep using the word stereo lithography file instead of the standard triangle that list what they have done. So, I use this file. Then you have a SketchUp, I do not know if it is still valid. So, right now no, you are likely to find SolidJet, SolidWorks, then some other related thing, and then so we have lot of this stuff about seen this, no, how this thing can be made. What is FDM, what does it work and all that. No, I suggest before I start explaining, you read it. So, both we have generically it is called fused deposition. Fused filament fabrication is a stuff which we have. FDM is mostly used 3D printing, and so the word printing has come. You see here at the bottom, no, you have the support material, something does support at the bottom, and then the top, no, that thing starts printing the actual object. So, we have here some of them have 2 types of material, some of them do not have 2 types of material. Instead, the same material, a small thin this thing is printed which will eventually be broken. So, I suggest no, you please read this thing. So, here you have seen this. I will see if I can enlarge this and show you, which I keep on what you call keep on mentioning again. You see here at the bottom, you have the support material, on the top you have the part. But then if you look at the spacing here, that is where they had given the thing about what is the bridge. Depending on the type of material and depending on the type of feature size, bridge width varies. So, I think I leave it to you to read the stuff about this 3D printing which is given here. So, other options are also given which allow me to go back. Now, similarly, other manufacturers, other people who maintain this have given huge amount of data on how to maintain these things. So, what to do with the surface normals, holes and open edges, duplicate surfaces, hollowing parts. Bottom, few references are given saying what could be a duplicated edge. Is a solid object, this is a surface object. So, you have to be very, very careful on how do you play with these objects. Then, what is the normal direction? This is an inverted normal. You see here there may be a problem about how these things build, and You have seen this here. If you see carefully, some problem has happened here. There is an unfilled hole, which if you remember yesterday when I was trying to fill at the corners, this thing happened. Then there are, you need to make sure that these openings and all are completely covered, that there is no error. Most of the time the current 3D printing software helps you identify these things automatically, and this happens to me often because of the various types of trying to build things. You see here I ended up with a visible duplicate surface. So, I do the easy way out. I select what I want, export it to a different file and try to manipulate the file on the outside. So, we have here saying sizes of the details. See here, lot of thing has been built inside in spite of these steps and all that, no, they are trying to make it by making this particular thing. Why it looks so small? It is not a real lamppost. This was made for a model railway. So, you have that 9 mm, then you have HO, then you have standard what you call model trains. So, somebody has spent a lot of thing and probably printed it at home. And you see here, if you see two objects here, for example, this is probably part of a architectural model. So, when you build a house, you need to make an architectural model. Now, it is easy for us to print all the features, and I would rather use a combination of foam board and these other things for railings inside and all that we can do. In this case, this is a railing with glass panels. So, left is what the model has been made because it looks interesting and probably it is traced from an available thing, but the reality is this such thing can't hang on in the air. So, instead, as in real life, you need to have these connectors which will ensure that the objects stay in place, they can't be in the air. To reduce waste and save on cost, large volumes of parts can be made hollow. So, this also probably was part of the, it is an exercise, then how to build things and all that. Now, we have this stuff about one way of producing large prints that exceed a 3D printer's build envelope is to split the data into 3 sections, print them and join the sections together, past printing. So, I have a huge this thing. If you see, this is the house. This house has been made into the left part, right part and the middle part have been cut here. So, that is one here. You have the left and you have the right, and typically something which is about what you call 150 mm, 150 mm and 100 mm high is easy to print. Remaining is how much dependent. So, here you see somebody has given a nice roundup of how these things work. I think I will stop this lecture here, I will continue with the sample next.